Hey everyone, and welcome to this explainer. Today, we're taking abstract, sometimes intimidating math, and we're literally turning it into a concrete roadmap for your business data journey. Oh, and since we're going to be diving into some pretty dense concepts, definitely feel free to turn on the CC, the closed captions, to read along. Also, if you're looking to really elevate your company's analytics, teaming up with expert partners like Panaki IT Consultant Private Limited, you can check them out at panakiithelp.com, can absolutely be a game changer. All right, let's dive right in.
Okay, here's our roadmap for today. We'll breeze through the foundation of decision-making, gathering the right data, summarizing that data, visualizing distributions, finding relationships, and then, the best part, drawing powerful conclusions.
Let's kick things off with Section 1, the foundation of decision-making. Before we do anything, we really need to establish the bedrock of why we even bother looking at numbers in the first place.
So what exactly is statistics? Well, it's the process of collecting, organizing, analyzing, and representing data for better decision-making. Look, it isn't just some dry math requirement you might remember from high school. It is literally the ultimate business tool. Think of it as the bridge that takes your company from just guessing what the market wants to making rock-solid, concrete decisions based entirely on factual data.
Now, this whole process actually splits into two really distinct paths. First up, we've got descriptive statistics. This basically summarizes the sample data you've actively collected. It's like taking a snapshot of what's happening right now. Then, inferential statistics takes the baton. This helps you conclude things about your entire market. You're basically using that small sample to make these incredibly powerful predictions about the broader population. Pretty cool, right?
Moving right along to Section 2, gathering the right data. Because hey, before we can analyze anything at all, we've got to gather the right raw materials. Here's the thing, your insights are only as reliable as the sample you collect. You've got four main techniques here. You might go with simple random sampling where every single member gets an equal chance of being picked. Or you could use stratified sampling. That's where you split the population into non-overlapping groups, making sure all your customer demographics are perfectly represented. Then there's convenience sampling, which is great to tap directly into expert knowledge within your industry. And finally, systematic sampling, taking every nth interval, if you're looking for a highly structured, rigid approach.
You also need to know exactly what kind of variables you're tracking. These range from simple categories in nominal data, like, say, tracking customer locations by state. Then we step up to ordinal data, where the rank actually matters, kind of like a priority list. Step it up again to interval data, where both order and value matter, but there's no absolute zero. And finally, the big one, ratio data. This has a true absolute zero. Think of things like temperature, your daily revenue, or total website clicks.
All right, let's transition into Section 3, summarizing your data, and see how all this builds into finally making sense of the noise. Imagine you're staring at a massive, endlessly scrolling spreadsheet of customer information. You need to find the center of it, right? To do that, you'll look for measures of central tendency. You can calculate the mean, which is just your standard average. You can look for the mode, the element that pops up the most frequently, or you can find the median. And let me tell you, the median is incredibly useful for business because it represents the exact middle element. That means it doesn't get horribly skewed by crazy outliers, like that one single client who happens to spend 100 times more than everybody else. But what about the rest of the data? To understand how spread out your customer data is from that center point, we use measures of dispersion. So while central tendency gives you the middle, metrics like variance, range, and standard deviation tell you the exact distance from that center. This is huge because it reveals whether your customers are all behaving very similarly or if their habits are just wildly dispersed across the board.
And this brings us to the 5-number summary, which uses percentiles and quartiles to give you a crystal clear picture. By visualizing your data in a box plot, you can clearly box in exactly where the bulk of your data lies, right there in the interquartile range. But more importantly, it helps you instantly spot those extreme outliers at the maximum and minimum edges. Those are the sneaky points that might secretly be throwing off your entire business strategy.
Okay, on to Section 4, visualizing data distributions. We all know numbers on a screen are great, but the human brain, and let's be honest, your business stakeholders, crave visual stories. So, we start by bucketing discrete data into a histogram just to see the raw counts, but to see the true trend, that's when we apply a kernel density estimator, or KDE for short. Think of KDE as this magic smoothing process. It infers the behavior of your entire population from your finite sample, turning those blocky, jagged bins into a beautiful, smooth probability density curve. That curve reveals the true underlying trend of your data. Now notice how the top of this perfectly symmetrical bell curve houses your mean, median, and mode exactly in the dead center. When your data takes this specific, classic shape, you are looking at a normal distribution. In the business realm, finding a normal distribution in your data is absolutely fantastic. Why? Because it makes predicting future consumer behavior incredibly reliable.
But wait, what happens if you have data sets in wildly different units? Say you're comparing website traffic in the millions to a conversion rate in single digits. Well, that's where standardization comes to the rescue. It scales everything down to a standard normal distribution, mapped by z-scores. Now, suddenly, your mean is 0 and your standard deviation is 1. This process is absolutely crucial. It actually saves machine learning algorithms a massive amount of processing time because it brings all your distinct variables to the exact same scale. It's a total game changer.
Next up is Section 5, Finding Relationships in Data. This is where we start asking the million-dollar questions. How do these variables actually interact with each other?
To figure that out, we look at correlation. Correlation assesses the linear relationship between two variables. It ranges from a perfect -1, where the line slopes evenly downwards, all the way to a perfect +1, sloping evenly upwards. If your correlation value is 0, kind of like in that completely scattered box on the right, it means those two variables just aren't dancing together at all. There's no relationship.
But hey, what if the relationship isn't a perfectly straight line? We can use Spearman's rank for that. This specific calculation assesses monotonic relationships. It lets us see if those variables are still moving together in a predictable direction, even if they aren't completely linear. This is incredibly practical because, let's face it, real-world business data rarely falls perfectly into a straight line.
Finally, we reach the climax for our business audience, Section 6, Drawing Powerful Conclusions. This brings us right back to the incredible power of inferential statistics.
When you want to definitively prove a hypothesis, you run tests. A one-sample t-test is fantastic for comparing your single population to a standard, say, countrywide value. But if you want to see if your brand new marketing campaign actually worked, you wouldn't just guess, right? You'd use a paired t-test to scientifically compare your exact audience's behavior before and after the experimental intervention.
And when you run those tests, you're going to get a p-value, which represents your significance level. To translate this perfectly to a business mindset, the p-value simply tells you exactly how many times out of 100 your experiment is going to fail. It is a highly quantifiable, incredibly useful measure of business risk and confidence.
So, as we wrap up this explainer, I want to leave you with this question to really ponder. How will you apply these statistical tools to your data to drive your next big business decision? Transforming raw information into actionable strategies is exactly what separates the leaders from the followers. And as you embark on this data journey, remember that you absolutely don't have to do it alone. Expert teams like Pinaki IT Consultant Private Limited are ready and waiting to help you out over at PinakiITHub.com. Thank you so much for diving into the numbers with me today, and I'll see you next time.